Algebra 2 Logarithms. The goals of this lesson are to cover all logarithmic properties, solve exponential and logarithmic equations, and convert exponential expressions to logarithmic expressions, and vice versa. Let's go over the logarithm rules. So first, as a basic, whenever you see just log of x and the base isn't identified, always assume that base is actually 10. And if you have a log where the variable is the same value as the base, so log base b of b, that's always equal to 1. So for the product rule, this covers if two variables being multiplied, you can separate them as two separate terms through addition. So log base b of m times n would be log of base b of m plus log base b of n. And the quotient rule is the opposite. If you had two variables being divided in a log, you can separate those as separate terms by using subtraction. So log base b of m over n is equal to log base b of m minus log of base b of n. And then here's the power rule. Whenever you have a log raised to a power, you can always move that power in front of the expression. So log base b of m to the power of n, it would become n times log base b of m. And changing the base rule, just memorize this formula because sometimes they'll expect you to change from log base 3 to log base 10. So if you had log base a times b, you would make it equal to log base c, or whatever base you are converting to. So log base c of b over log base c of a. And this could also be in the form log base a of b, the original, times log base c of a, your new base, and the base of your previous log is equal to log base c of b. So that's your new base and the original variable. And then you have the equality rule. If you have two logs that are equal and the bases are equal, then the variables are also equal. So log base b of a is equal to log base b of c. Therefore, we definitely know a is equal to c. And if you have a number raised to a log and the base of the log is equal to the number that's being raised, then the answer is the variable in the exponent. So b raised to the power of log base b of x would just be equal to x. And whenever you have a negative log, you can make a positive by finding the reciprocal of the variable. So negative log base b of a is equal to log base b of 1 over a. Now let's do some practice with solving logarithmic expressions. If you had log 36 minus log 6, let's apply the rules that we learned. This would be log base 10 of 36 over 6, and that's equal to log base 10 of 6. What if you had log 36 plus log of 6? Then you have log base 10, 36 times 6, and that's equal to log base 10 of 216. If we want to simplify this further, we know that 216 is 6 to the power of 3, so this becomes 3 times log base 10 of 6. And what if you had log 36 times log of 6? Then you could do log base 10 of 36 plus log base 10 of 6. And then what if you had log 36 divided by log 6? Then it would be log base 10 times 36 minus log base 10 of 6. Now let's practice writing an exponential and logarithmic form. So if you had log base 3 of x is equal to 9, how can you convert this to exponential form? Let's follow the rule BAE, or BAE. So just align the letters BAE in that order to the variables. So base 3 is B, x is A, and 9 is E. So this stands for base, answer, exponent. So 3 is the base, 9 is the exponent, so it's 3 raised to the power of 9, and x is the answer, so that's set equal to x. So x is 3 raised to the power of 9. What if you had log base 2 of 8 is equal to x? Let's set up BAE. 2 is base, x is the exponent, 8 is the answer. So 2 to the power of x is equal to 8. Now, what about moving from exponential to logarithmic form? What if we had x is equal to 3 to the power of 2? This is the reverse of what we previously did. So as you can see, x is the answer, 3 is the base, and 2 is the exponent. Now, what if we wrote this in logarithmic form? Remember BAE? So it would be in that order. So log base 3 the base, x the answer, is equal to 2 the exponent. Now what if we had 27 is equal to 3 to the power of x? Remember, BAE, but in reverse. So it will be 27 is A, 3 is B, and x is the exponent. So we know this is log base 3 times 27, which is the answer, and x, which is the exponent. Now let's rewrite expressions into single logs. Let's say you had 2 times log 4 plus log 16. This is log 4 raised to the power of 2 plus log 16. 4 to the power of 2 is 16, so it's log 16 plus log 16. Remember the multiplication rule? So we're going to do log 16 times 16, which is log 256. But what if you had 2 log 4 minus log 16? So it's log 4 squared minus log 16 minus log 16, log times 16 divided by 16, which is equal to log 1, which is always equal to 0. Now, let's practice expanding logs. If you had log times 3x squared y to the power of 7, how can you expand this? So we would make it a log of these as each as a different term, separated by addition. So it would be log 3 plus log x squared plus log y to the power of 7. And remember, we can't leave it in this form. These are exponents. We can move them in front of the logs. So it could be log times 3 plus 2 log x plus 7 log y. So let's say we had log times square root of x squared y to the power of 4. This would be log x plus log y to the power of 4 over 2, and that's equal to log of x plus log of y to the power of 2, which is equal to log x plus 2 log y. What if you had log times 3x squared y to the power of 7 all over the square root of x to the power of 4 y to the power of 2? This may look tricky, but we're still going to separate this using addition and subtraction. The numerator will be separated by addition because it's being multiplied, but the denominator will be separated by subtraction because it's being divided. No, it's doing the dividing. So you would have log 3 plus log x squared plus log y to the power of 7, but then you're going to minus log of x to the power of 4 over 2, and you're also going to minus y to the power of 2 over 2, because remember we're finding the square root of those terms. So it will be log 3 plus 2 log x plus 7 log y minus 2 log x minus log y. Now let's work with changing the basis of logs. Remember the change of base formula. So if you had log base b of x, it will be equal to log base a of x over log base a of b. So let's say you had log base 3 is equal to 24, and you want to make it have a log of base of 10. So you would make it log base 10 of a, which is the original term, and then log base 10 of the value of the base, which was 3. So it would be log base 10 of 24 minus log base 10 of 3. Now what if you had log base 3 of x? So you're going to set it up in the same way. It will be log base 10 of the original value, x, and it will be log base 10 of the value of the base, which was 3. So it will be log base 10 of x minus log base 10 of 3. Let's work with changing the basis of log and dealing with log, but what if we needed to know natural log? Natural log is the same thing as log base e. Therefore, if you multiply natural log by e, this would equal 1. Because remember the rule of an equivalent base and number, log base e times e would be equal to 1. You still treat logarithms the same, like with the same rules, if you have natural log instead of regular log. So if you had natural log of 9 is equal to x, you can multiply e to get rid of the natural log, and it will be 9 is equal to e times x. 9 divided by e is equal to x. And e is equal to 2 point something if you ever need to substitute it. What if you had 2e raised to the power of 2x is equal to 24? You could divide by 2 on each side. E raised to the power of 2x is equal to 12. 2x is equal to natural log times 12. X is equal to natural log of 12 over 2.